Hi, my name is Matt Rockage.
My name is Anthony Panucci.
My name is Zach Thomas.
And our advisor is Professor David Loker, and our sponsor researcher is Greg Dillon. And our project is the High Temperature Thermoplastics 3D printer for experimental research.
The Penn State Barron Plastics Department needs a device to print high-temperature thermoplastics, such as a material known as PEEK. The printer's purpose is to aid in researching 3D printing material and its strength properties at any given temperatures up to 500 degrees Celsius. PEEK, known as polyether ether ketone, is a special plastic that is non-metallic and can have yield strength to some mild steels when properly crystallized, and can be used in industry for aerospace parts or even biomedical implants. This is the main material that will be experimented on in this printer.
The main hot end nozzle will be able to get up to a max temp of 500 degrees Celsius to ensure the correct flow for materials.
The bed of the printer has a max temperature of 350 degrees Celsius as well for the chamber to ensure great layer adhesion and great bed adhesion. Here we are using the Duet 3D web interface to control the printer so that we are able to start prints, check the job status, and even reconfigure the main G-code source files from the set file set list. This will allow us to tune and add more functionality to the printer if anything needs changed, or if we want to add another extruder later on in the future. You can also set temperatures manually from the front tool panel for the extruder nozzle, the bed, or even the chamber. On top of the printer, we have an LED indicator light to tell us if the status of the printer is green, ready to use, yellow, hot and in progress, or red for the emergency stop system, along with a buzzer to alert the user if anything's wrong.
As an extra safety precaution, there is an Arduino Mega with 8 temperature sensors constantly monitoring the thermal status of the printer's bed, inner and outer chambers, as well as the electronic power boxes to ensure that nothing is being overheated. If one of the temperature sensors were to fault, then the emergency stop relay will activate and open the high power contacts to ensure that the power is disconnected.
As normal 3D printers use stepper motors for the X and Y gantry, we opted for ClearPath servo motors. The advantage of using servos is that we will be able to control the amount of torque added into each axis, and will be able to get 1G of acceleration for sharp edges on cornered parts.
With the high temperature 3D printer all assembled and within our design restraints, we are able to print high temperature material tensile bars for experimental research, stress testing, and